6.6, inverse of a function. So we are going to be solving to find the inverse function of each function given. And what that means is we are basically going to be switching the x and y values. So first, let's just start with example 1. It says let f of x equal 2x plus 3. And so then we are going to, on the first one, we're going to solve y equals f of x for x. Well, when it says y equals f of x, all we're going to do is change that f of x right there to y. So now we're going to write down our function f of x equals 2x plus 3, and just change f of x to y because we know that they are the same thing. So y equals 2x plus 3, and it tells us to solve for x. So we're just going to get x by itself, where in the past we always got y by itself. So right here, we are going to subtract 3 from both sides. The 3's cancel, and we have y minus 3 equals 2x. To get x by itself, we have to get rid of that 2. So we're going to divide by 2 on every piece. So now we have, now remember, if you're dividing a variable by a number, you always have a number in front of that variable, no matter if it's actually there or not. So we have an understood 1 right there. That right there can be rewritten as 1/2 y minus 3/2, or 3/2, equals, and those 2's cancel, we have x. Now, the one thing I am going to do is rewrite this with the x in the beginning. So x equals 1/2 y minus 3/2. And there we go. We've solved for x. All right, let's do another one. This one says find the input when the output is -7. Well, let's write down what we found here. We have x equals 1/2 y minus 3/2. And so input and output. Well, input is your x value, output is your y value, always. Input is x, output is y. So if we're finding the input, we're finding the x. And it tells us that the output is -7, so the y value is -7. So let's plug that in. X equals 1/2 times -7 in place of y minus 3/2. Now guys, you can put that part right there directly into your calculator. Whoops, there we go. Alright, so if you put that directly into your calculator, you are going to put in 1 divided by 2 times, in parentheses, -7, close your parentheses, minus, make sure you use the minus and not the negative, 3 divided by 2. Press enter, and you come out with -5. So, right here we have -5. But I need to see where you're plugging that in. So make sure you have those steps written out. Alright, so now let's go to example 2. Find the inverse of f of x equals 3x minus 1. Well, finding the inverse, there's several steps that we're going to go through here. The first step, step 1, we are going to change f of x to y. So let's go ahead and do that over here. If I have f of x equals 3x minus 1, I'm changing that to y equals 3x minus 1. Now, step 2, is I'm going to solve for x. Okay, so let's go ahead and do that. If we're going to solve for x, we're getting x by itself, just like we did in example 1. So let's add 1 to both sides. On the right side, they cancel. On the left side, I get y plus 1 equals 3x. To get x by itself, I need to now divide by 3 on everything. On the right side, they cancel. On the left side, remember, you have an understood 1 in front of that y. So now I have 1/3 y plus 1/3 equals x. And just like in example 1, we're going to flip that around. So we have x equals 1/3 y plus 1/3. And now we have step 3. In step 3, we are going to switch the x and the y value. So our x is here, our y is here. We're just going to switch them, and we're going to write it as y equals 1/3 x plus 1/3. So all we did is we let the y and the x switch places. And now for step 4, we are going to change y to f inverse of x. So f inverse of x, that just has the -1 in that exponent on the f. So that just means that's an inverse function. So f inverse of x is equal to 1/3 x plus 1/3. And this is your final answer. Okay, f inverse of x equals 1/3 x plus 1/3. Hopefully you make sure you write down all step 1 through 4 on this example so that you'll have those to refer back to. I'm not going to ask you to write down steps 1 through 4 on each of those problems, but you need to make sure that you are actually performing those steps. So make sure that they're here in your notes. Okay, so now let's look at a few more of these. And right here, this says graph. I'm not going to graph these right here, because we are just working on finding the inverse right now. Now, whenever you do your assignment, if it tells you to graph, then yes, by all means you need to graph. But right now we are just working on finding the inverse. So, number 4, f of x equals 2x. Step 1 says to change f of x to y. So here we go, y equals 2x. And if you want to keep up with that, you can write your little step 1 right there just like that. You don't have to write down all of the words. Now, step 2, we are going to solve for x. So to do that, we're going to divide by 2 on both sides. 2's cancel. Remember, there's an understood 1 right there. So I have 1/2 y equals x. And we need to flip that over, so we have x equals 1/2 y. Step 3. In step 3, remember that you switch your x and your y. So now they're just going to switch places, and I have y equals 1/2 x. And step 4, change y to f inverse of x. So here we go, f inverse of x equals 1/2 x. That does not look like a 1/2 there. Let me fix that. There we go. Alright. Let's look at a couple more of those, and then we will move on. So looking at number 5 here. Step 1, change f of x to y. So y equals -x plus 1. Step 2, solve for x. So So let's subtract 1 from both sides. We have y minus 1 equals negative x. So we're going to divide both sides by negative 1. Divide everything by negative 1 to get rid of that negative in front of the x. That's going to cancel. Y divided by negative 1 is negative y. Negative 1 divided by negative 1 is positive 1 equals x. And don't forget to flip that around. So x equals negative y plus 1. Step 3. Switch the x and the y. So we have y equals negative x plus 1. And step 4, f inverse of x equals negative x plus 1. And we have found our inverse function. Now, on those that you do have to graph, all you're going to do is you're going to put the original that it gives you in the problem in the calculator, and then what you find right here, you put it in the calculator as well, and it will graph both of them. We'll look at that here in just a second. All right, so number 6. 1, change f of x to y, so y equals 1/3 x minus 2. Step 2, solve for x. So we are going to add 2 to both sides. They cancel on the right, and I get y plus 2 equals 1/3 x. Now, to get rid of that 1/3, I'm going to multiply by 3 on both sides. 3 times y gives me 3y, plus 3 times 2 gives me 6, equals 1/3 and 3 cancel out, and I'm left with an x right there. Flip that around. X equals 3y plus 6. And we can move to step 3. Step 3, switch your x and y. So we get y equals 3x plus 6. Step 4, change y to f inverse of x, and it equals 3x plus 6. There we go. All right. From there, we are going to go ahead and move on to example 3. Example 3 does have some graphing, and it says find the inverse of f of x equals x squared when x is greater than or equal to 0, then graph the function and its inverse. So we'll have some graphing experience here. So first of all, we're going to start off with f of x equals x squared, because that is the function we are given. Step 1, we are going to change f of x to y. So y equals x squared. Step 2, we are going to solve for x. So we have to take the square root of both sides of my function because I am solving for x. So to get rid of that square, I have to take the square root. Now then, when you have this and you take the square root, the square and the square root cancel on the right side, and you have x equals. When you take the square root of that left side, you have a plus or minus. So now I've got plus or minus the square root of y. Let's flip that over and get x equals plus or minus the square root of y. Now, one thing that you need to pay very close attention to is that plus or minus right there, and we will take care of that at the very end, and we'll go back to what it says in the beginning of the problem. Let's go on and find our function. Step 3, switch x and y. So now I have y equals plus or minus the square root of x. Step 4, change y to f inverse of x, and that equals plus or minus the square root of x. Now, here we go. When at the very beginning, it says that x is greater than or equal to 0. So if x is greater than or equal to 0, that means it must be positive. So I'm going to put a little note to the side out here. X greater than or equal to 0, only positive. That means whenever we write down our answer here, it's going to be f inverse of x, just the positive square root of x. I don't need the negative because of the stipulation the problem gave me. So there's the first part where it says to find the inverse when x is greater than or equal to 0. Now it says to graph the inverse and its function. So whenever I graph, and in this inverse, it says x squared when x is greater than or equal to 0. So it doesn't want the entire x squared. So let's put this in our calculator real quick. Let's clear everything we have in there. And we're going to go to tab. Going crazy. There we go. X squared. And I'm going to go ahead and put in the second one as well. Square root of x. Alright, so you notice the x squared is the parabola, but they told me to only do when x is greater than 0, so I just want x greater than 0 right there. I only want that part, so I don't want the left side. So when I graph that, and you can look at the table to get your points, but when I graph the original function, I have 0, 0, 1, 1, 2, 4, 3, 9, and we'll stop there. Go ahead and graph that. So this is my f of x. Then, when we graph our inverse, you can again get a table. It's the square root function. So I have 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 2, 9, 3, and we can graph that function. Now, this is my f inverse of x. So there's the original function and its inverse. And of course, the graph on the calculator looks a lot better than the graph that I drew. But if you notice, I have a dotted line through here. That dotted line is the line y equals x. The reason for that, remember on step 3, we switch the x and the y. So when we switch the x and the y in our function, we switch the x and the y in the table as well. So just to show you that, we're going to go ahead and write down the table for each of those. So if I have x and I have f of x, the points that I used, we had 0, 0, 1, 1, 2, 4, and 3, 9. For our inverse function, we had x and then f inverse of x. We still have 0, 0, we still have 1, 1, and we have 4, 2, and 9, 3. So you can tell right here and right here, the x and the y are switched. So they just switch places just like they do in step 3 of the function. Okay? So moving on here. Write down this core concept. It is a horizontal line test. So in this horizontal line test, it says the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So if I have my original function right here, this cubic function, and instead of drawing a vertical line to see if it's a function, I know it's a function. I want to know if the inverse is. So I can draw a horizontal line through there, and it only hits one time, so it's a function. So the inverse is a function. Now, on a quadratic, if I draw a vertical line through there, I know it only hits once, it's a function. So now I can check the inverse by simply drawing a horizontal line through. That horizontal line hits twice, so the inverse is not a function, which explains why in the previous problem it was restricted only to x is greater than or equal to 0. So, moving on here, example 4. Consider the function f of x equals 2x cubed plus 1. Determine whether the inverse of f is a function, then find the inverse. So, I have that function right there. We're going to put that into our calculator right fast. We have 2x cubed plus, so there we go, plus 1. All right, so that's what our function looks like. We're just going to come over here and sketch it. I'm not even going to put any numbers on my graph. I'm just going to sketch the shape. So now, determine whether the inverse of f is a function. Well, I can look at that graph right there, and anywhere on it, draw a horizontal line. It only hits once, so yes, it is a function. Then I have to find the inverse. So let's go with our steps. Step 1, change f of x to y. So I have y equals 2x cubed plus 1. Step 2, solve for x. So I'm going to subtract 1 from both sides. I have y minus 1 equals 2x cubed. Divide by 2 on everything. Remember, there's an understood 1 right there, so I have 1/2 y minus 1/2 equals x cubed. To get rid of that cube, I have to take the cube root of 1/2 y minus 1/2, and I have to take the cube root of x cubed. So the cube root and the cube cancel each other out, and I get the cube root of 1/2 y minus 1/2 is equal to x. We're going to flip that over. X equals the cube root of 1/2 y minus 1/2. Step 3. Remember, step 3, you switch your x and y. So now I have y equals the cube root of 1/2 x minus 1/2. And last but definitely not least, step 4, change y to f inverse of x. And we still have our cube root of 1/2 x minus 1/2. There's our function. Okay. So again, it said, consider the function, determine if it is a function, and then find the function. Determine if the inverse is a function, I'm sorry. So make sure, all you have to do is just sketch that little graph, put it in your calculator, sketch it on your paper, show me the horizontal line. You just sketch, I didn't put any numbers on that graph at all. Then, yes or no. If no, you can't do anything else. If yes, then you go ahead and find the rest of it. All right. Example 5, consider the function. Determine whether the inverse of f is a function. Find the inverse. So again, we're going to go back to our calculator. Plug in the function we are given. My calculator's spazzing out. There we go. 2 square root of x minus 3. And so that's our function right there. So we are going to just sketch. There we go. So to determine whether the inverse is a function, I'm going to just simply draw a horizontal line through it. It only hits one time. So yes, the inverse is a function. Now I have to find the inverse. Step 1, change f of x to y. So y equals 2 square root of x minus 3. Step 2, solve for x. So first, I'm going to divide by that 2 that's out front. Remember, there's an understood 1 in front of the y. So I have 1/2 y equals, those cancel, the square root of x minus 3. To get rid of the square root, I am going to square both sides. So now I have 1/2 squared, which is going to be 1 over 4, y squared, which is y squared, equals the square root and the square cancel, x minus 3. Now we are going to add 3 to both sides. Those cancel, and I get 1 over 4 y squared plus 3 equals x. Flip it over. X equals 1 over 4 y squared plus 3. And now, on to step 3. X and y switch places. Y equals 1 over 4 x squared plus 3. And step 4, we have f inverse of x equals 1 over 4 x squared plus 3. But one thing we have to take into account is that if I were to graph that green function right there, I would come up with something that looks like this right here. Well, if I flip this first function over that dotted line, I'm not going to get both sides of that. I'm only going to get the right side. So I need to restrict my inverse function to only be positive. So we're going to put x is greater than or equal to 0. So pay close attention to that, because sometimes you need to do that and sometimes you don't. So you're just going to have to make sure you're paying very close attention. Make sure when you graph both of them that they look the same. It's just a mirror image across that line, y equals x. So now we have example 6, last one here. Example 6, determine whether this and this are inverse functions. So to do that, we are going to do a composition of functions. What that means is we're just going to plug one into the other. So if I'm starting with f of x here, it equals 3x minus 1. Then I'm going to take and plug g of x into f of x. So where I have that x right there, I'm going to put the other function, x plus 1 over 3, and then continue on with my minus 1. So instead of that x, I put x plus 1 over 3. So now let's just work that out. Well, right here, the 3 over 3 will cancel, and I'm left with x plus 1 minus 1. Plus 1 minus 1 will cancel, and I have x. And that's what I want. So I want f of g of x to equal x, and that time it does. Now I have to check it the other direction. So I have to take my g of x function, which is x plus 1 over 3, and I have to plug f of x in. So I have g of f of x. So now instead of that x right there, I'm going to put my f function in parentheses, 3x minus 1, then the plus 1 from the top of the function over 3. Now, you have to work on the top of the function first. That is in parentheses, but I can't do anything inside there. So I have the minus 1 and plus 1 that cancel. On top of my fraction, I still have 3x. Bottom, I have 3. 3 over 3 cancels, and I have x. So g of f of x is equal to x. It checks out. So then I can write down that f of x and g of x are inverses. And there we go. That's our answer. You have to make sure you show all of that work.